Reciprocity theorem. Today we'll start again the reciprocity theorem. You can see right now?
Yes, ma'am.
Yes, ma'am.
Okay. In any linear bilateral network containing any one independent source, the ratio of what we do in this reciprocity theorem, we take the ratio of excitation to response. That is important. The ratio of excitation to response is what remains constant when the position of excitation and response are interchanged. So you have to keep these two things in mind. One is excitation and one is response. The ratio of excitation to response remains constant. So for example, you take the excitation as voltage source and the response as the current. So just first find out the current I as usually. You can go with node or mesh analysis and find out the current I. Then interchange the position of this response and excitation. So interchanging is very important. This voltage source should just come to here, to this position, and the current source should go, the voltage source should come like this, okay, in this way only. So the arrow mark should be down and the current source should go in this direction. Just the excitation and the response should be interchanged, and again you have to find the response, or again you have to find V by I ratio. If it remains constant, that means the reciprocity theorem is verified. So in this network I have just changed the excitation and response position. The voltage is here and the current is here, and by using that theorem, yesterday we had solved one just simple example. Today we'll go with our AC source. Okay, all the J terms will be done today. After completely doing, we can come with, if you have any doubts, you can clear. So first, all the problems are very important, and this reciprocity theorem has some very few problems, and that will be always repeated. Okay, so this is one of the problem here. Verify the reciprocity theorem for the given network. See here, you have to observe here we have a 2 ohm resistor and 2 ohm capacitor. This is the symbol of capacitor. Okay. Again we have 1 ohm resistor and 2 ohm inductor. Getting it? It is a 2 ohm inductor. Next we have again 2 ohm resistor, 2 ohm inductor, 10 ohm capacitor. See, everything is written in terms of ohms. Fine. We can't take this like directly because capacitance should be written in terms of minus J. In terms of minus J, you have to write capacitance. Okay. And inductance should be written in terms of plus J. Okay. That is written here. Minus J represents capacitance and plus J represents inductance. So what will happen? This is, it is not 2 ohm. So when you use it, it will be minus 2J. You have to remember that minus 2J, and this will be plus 2J. Here also, this also will be plus 2J, this inductor. Fine. And this capacitor will be minus 10J. This is nothing but minus 10J. Okay, you have to write in that way. Whenever they give like this, you have to convert them into J terms and then solve the problem. So we'll go with the node analysis here. They have told you to verify the reciprocity. Here, is a 10 at a 100 at an angle 0. Okay, that is the voltage source, that is the excitation, and the response is the current I. So first we have to find current I. To find out the current I, if I come to know the voltage here, what will be the voltage? Okay, that voltage divided by this resistance will give me the current I. You can go with mesh analysis also. I'm just solving by node analysis here. So there is only one node. Okay, in node analysis, again I'm mentioning, we will go with the KCL, Kirchhoff's current law. We will write current in terms of voltage and resistance. That is what we do. So since we have only one node, and assume that all the current is moving away from the node, and the current moving away from the node is taken as positive, and the current coming towards the node is taken as negative. That is the assumption. So how many branches we have at the node? We have 3 branches. So we have to write 3 equations for current. So for this branch, there is a voltage source here, and we have assumed a voltage V. So the difference in the voltage, that is V minus 100 at an angle 0. See, this is the arrow mark. The arrow mark, this represents plus and this represents minus. Fine. The head of the arrow represents plus and the tail represents minus. So since it is plus here, we'll write V minus 100 at an angle 0 divided by resistance. Resistance is how much? 2 minus 2J. See, that is written here. 2 minus 2J. Okay, combining. So this is voltage and this is resistance. So voltage divided by resistance represents one current. Okay, branch of one current. Next, what you will write? Next, for always the node analysis, there is a ground node that is written here. So next is V minus 0 divided by minus 10J. Okay, this is a capacitance. So you'll write minus 10J plus V, again it is connected to ground, V minus 0 divided by, see this resistance, it is all are in series, they are added. So 1 ohm plus 2 ohm, it is 3 ohm. Getting it? Or you can just write it as 3 ohm plus 4J, or you can write as 1 plus 2J. Okay, 1 plus 2J, 2 plus 2J. It is written. So you can combine that and write. So 2 plus 1 will become 3. 2 plus 2 is 4. You can combine here also. From here only you can combine. It is 2 plus 1, 3. 3 plus 4J. The combination of this. So we have 3 branches. We have written 3 currents and that is equated to 0. As usual, take all the, only V is the voltage. Take the V common outside. Okay. You have to put this in your calculator. Fine. This first LHS put in the calculator. So in calculator, you have to put in the complex mode. Your calculator should be kept in the complex mode. Okay. And then you have to use this J terms. So whenever we write this 10J, it cannot be written directly in calculator as 10J. Fine. It is written as 10I. Okay, and I comes above that engineering button, ENG1 button is there. Above that word, that this alphabet I will be there. Just you have to substitute there. You have substitute this and you'll get the answer V as 18.92 plus 26.01J. Okay, this is in rectangular form. This is in rectangular form. In the calculator only you can convert them into the polar form. They have given a rectangular and polar. Whenever you press the function, second function, shift, whenever you press, you can convert them into the polar form. Next what I came to know now, this is the voltage V. So just finding voltage V will not complete the problem. You have to find I also, because we have to know the response here. So I is equal to V by R. So what is V now? V is 85.0, or the rectangular form is 80.92 divided by R. R is how much? 3 plus 4J. From where we got this, got 3 plus 4J, this is 3 plus 4J, this complete branch. That is 2 plus 1 is 3, 2 plus 2 ohm plus 2 ohm is 2J plus 2J is 4J. So we'll get 3 plus 4J. That is the current I. So this current I is the response. So this J is in rectangular term and this is in the polar form. It is 16.99, which is equated to, it is nearly equal to 17.01. So this is one current I. Okay. So because of this excitation, that is 100 at an angle 0, we got the response I by using node analysis. Fine. Next, what you have to do, we have to interchange the position. In reciprocity theorem, we have to interchange the position. So this 100 at an angle 0 should come this side and I should be brought to the LHS. Just interchanging the position, the network becomes. After finding I, go with finding the ratio, that is V by I. So excitation is 100 at an angle 0 and I is 16.99, which we got. So the ratio will be 5.88. Okay, this is the ratio, V by I ratio. Now interchange the position of excitation and response. So the I has been brought here. You can observe the arrow mark here. This is important. And the voltage source is brought here. Okay, the arrow mark is downwards and here the current direction is upwards. Now the position is interchanged. As usual, go with the node analysis. So it is V minus 0 divided by 2 minus 2J. Here it is 2 minus 2J. Here it is minus 10J. Here See here, you have to remember, represents what? The tail represents minus, the head represents plus. So V, whenever it is minus, you have to write plus. So it is V plus 100 at an angle 0. You have to observe this. It is V plus 100 at an angle 0 divided by combination of this. It is 3 plus 4j, equating it to 0. So take all the V terms one side, put in your calculator, you'll get the voltage V. So only V is not enough. We have to find out current I. So the current I is nothing but V by R. So how much is the R? R is 2 minus 2j. This I we want. Okay. We want I in this branch. So it is 2 minus 2j. So 2 minus 2j, we got the current I. It is nearly 16.99. So the ratio will remain same. So V by I, that is 100 at an angle 0 divided by I. So we'll get 5.88. So the ratio, whenever it has interchanged, the ratio remains constant. Since the ratio V by I remains same, the reciprocity theorem is proved. This is the method to prove the reciprocity theorem. We have gone here with the J terms. The answer also is been given. Please don't copy the answer. Solve the problem by using the calculator. Next problem also is very important. Many times they've asked this. Always preferably for reciprocity, they go with this problem only. So find the voltage Vx and verify the reciprocity theorem. So Vx is given here. You have to find the voltage Vx and verify the reciprocity theorem. See here, one important concept here is they have given a current source here. We have a current source here and there are branches here. So since I want voltage here, how I can get the voltage in this branch CD? If voltage depends upon what? V is equal to, what is the formula? I into R. Okay, V is equal to I into R. So if R is given, R is what? It is minus J3. This is R. So if I just is the current in this branch, that current into resistance will give me the voltage. So first I have to know what is the current. So how to find out the current? Since it is divided into two branches, I can go with the formula of branch current. Okay, what is the formula for branch current? The current in this branch, that is I2 is equal to main current into resistance of the opposite branch divided by sum of resistances. Okay, that is the formula for branch current. So I2 is equal to main current. Main current is how much? 5 at an angle 90 into resistance of the opposite. So I want the current in this branch. Okay, I2 have written. So opposite to that branch is which? It is 4 plus J5. So this is the opposite. So main current into resistance of the opposite branch is 4 plus J5 divided by sum of resistances. So you have to add everything. That is 4 plus J5 plus 3 minus J3. That is written here. 4 plus J5 plus 3 minus J3. So solve it. Put in the calculator, you will get the rectangular term and polar form is written. So I got the current here. Okay, we have found out the current here. Now we have to find out the voltage. So what is Vx? So whatever the current into minus J3 will give the voltage. So Vx is equal to I2 into minus J3. Just substitute I2 and minus J3, will get the voltage Vx. Getting it? After getting the voltage Vx, we have to find out the ratio. Fine. So the ratio is whatever the voltage divided by current. How much voltage we got? 13.18 divided by the current is 5 at an angle 90. See here, before we had seen the excitation was voltage source and the response was current. Here the excitation is current source. Okay, the excitation is current and the response is voltage. Okay, you should know that. So okay, find out V by I ratio. So V we found out it is 13.18 and I they have given already, it is 5 at an angle 90. So the ratio we got. Next what I have to do, we have to interchange the position. Okay, interchange the position. So whatever the current source was here, it is just brought here and the arrow mark is down. Fine. And the voltage source, the arrow mark is brought to this side and the arrow mark is towards the A. Okay, from B to A, the voltage source is written as Vx. It was here upside. So whenever it comes this side, it becomes downward. So again, we'll go with this branch current formula only. Here, finding out the branch is important. You should analyze correctly. See here, the branch here it is phi at an angle 90. Fine. So we have two branches. It is split here. It is shown here. This is I1 and this is I2. Fine. Here it is just open. I have to know the voltage here. So whatever is the I2 current, that I2 current will come till here. Okay, till here this I2 current will come. This is the opposite branch and this is the branch which we want current. Getting it? This branch, this minus J3 is the branch which where we have to find out the current, and the branch opposite to minus J3 is this complete one, because same current will be flowing here. There is no split here because it is open here. We have to find the voltage. So the so 4 plus 3 is 7. 7 plus J5. Getting it? 7 plus J5. I will show you now. First we will find out the current I2. Fine. To find out the current I2, what is the main current? Phi at an angle 90. Getting it? Phi at an angle 90 into minus J3. Why it is minus J3? Because this is the branch. I want the current in this branch. Fine. This is the branch. The opposite to this branch is only minus J3. For this branch, the opposite branch is minus J3. So phi at an angle 90 into minus J3 divided by sum of resistances. That is 4 plus J5 and 3 minus J3. So this concept should be clear. So the branch is this. So okay, when we take opposite branch, you should take only minus J3. This 3 ohm is included with this branch only. Okay, this both will come together. Since we want the voltage in this branch, okay, we want the voltage in 4 plus J5. Fine. So we have to know the what is the current. We want the voltage here, so we should know what is the current here. So the main current, that is phi at an angle 90 into resistance of the opposite branch is minus J3 divided by sum of resistances. Sum of resistances is 4 plus J5 plus 3 minus J3. So we'll get I2 here. Okay, after getting I2, what is Vx? Vx is equal to I2 into 4 plus J5. This is 4 plus J5. So we'll get Vx. So one voltage Vx is 13.19. So the ratio what we got? It is 13.919 and the current they have given already, it is phi at an angle 90. So the ratio V by I is nothing but 2.63 minus 54. So the ratio remains same. Hence the theorem is proved. So this is one very important problem where we use the branch current to solve it. The same problem with the different numbers is given as an exercise for you. Here the current is verify reciprocity theorem for the given network. Okay, the current is 10 at an angle 0. Okay, and we have 5 ohm resistor, 4 ohm and minus J4. So first we have to find out Vx or Vx voltage. To find out Vx, we have to find out I2 current. I2 current is equal to 10 at an angle 0 into resistance of the opposite branch is what? It is 5 divided by sum of resistances, that is 5 plus 4 minus J4. So you'll get the current I2. Current I2 into minus J4 will give us the voltage Vx. I2 into minus J4 will give us the voltage Vx. So the ratio V by I will get find out. Next, interchange the position. Interchange of voltage and response. So 10 at an angle 0 is put here and the voltage Vx. Again split the current and find out the current I2. We want the current in 5 ohm resistor. So the current I2 is equal to main current 10 at an angle 0 into resistance of the opposite branch is important. Opposite for this is minus J4. We should not write minus J4 plus 4. Okay, it is the 4 is also included here. Only minus J4 is opposite to 5 ohm resistor. That is important. Just find out the voltage and see the ratio V by I. Since the ratio remains same, the reciprocity theorem is proved. Thank you.